The topic is adding and subtracting whole numbers and perimeter. The objectives in this topic are add whole numbers, subtract whole numbers, find the perimeter of a polygon, and solve problems by adding or subtracting whole numbers. So adding whole numbers. An electronics store received a shipment of 2 boxes of iPods one day and an additional 4 boxes of iPods the next day. The total shipment in the 2 days can be found by adding 2 and 4. So total represents addition. And the 2 boxes one day and the 4 boxes the next day, if we add those together, we add 2 and 4, that gives us the total shipment in the 2 days. The total would be 6 boxes, and we call the result of an addition problem a sum. 2 and 4 are called addends. The things we're adding together are called addends, and the process of finding the sum is called addition. So similar words, very much related. They do mean different things. When we do addition, we find the sum of the addends. We find the total of the addends. That's the process of addition. So to add whole numbers, we add the digits in the ones place, then the tens place, then the hundreds place, and so on. So we go from right to left. We've got this floating answer here, 2,396. I'm going to take advantage of the fact that this answer is showing and revisit the idea of expanded form. The expanded form of this number would be 2,000 plus 300 plus 90 plus 6. And if we add the digits in the ones place, we get 6. If we add the digits in the tens place, we get 9. If we get the add the digits in the hundreds place, we get 3. If we add the digits in the thousands place, we get 2. That's one way that we can add some addends to get the sum of 2,396. It's also the answer to the directive add 2,236 plus 160. To add two numbers, we would line them up vertically so that the place values correspond. All the ones places are together, all the tens places are together. In other words, we right justify the two numbers. We line them up so that the completed column is in the right and not in the left. 2,236 with 160 written directly underneath it, lined up to the right, so that the ones correspond, the 6 and the 0, the tens correspond, the 3 and the 6, the hundreds correspond, the 2 and the 1, and the thousands correspond, the 2 and the nothing, the 2 and the 0 that we can imagine is there. Add from right to left. We go up in the place values. Start with the ones, then move to the tens. 6 plus 0 is 6. 3 plus 6 is 9. 2 plus 1 is 3. 2 plus nothing is 2. So that was easy enough. Done with addition, right? No. Sometimes, if the sum of the digits in the corresponding place values is more than 9, carrying is necessary. We could only fit one digit in each place value. What happens to the leftover digit? Well, we carry it. For example, if we have 365 plus 89, we'd write it vertically so that the ones places are together and the tens places are together. And then when we go to add from right to left, we go 5 plus 9. And 5 plus 9 is 14. So we're going to split that 14, how many ones is in 14? That goes in the ones spot. 14 has 14 ones. But that can be considered 110 plus 4 ones. So we put the 4 ones down, and now we have an extra 10. In other words, we keep the 4 and carry the 1. We've ripped the number apart. Now we add like normal. 6 plus 8 is 14, but we have that extra 1. That's a 15. Bring down the 5. Carry the 1. And remember, that 6 plus 8, that was technically 6 tens and 8 tens. So when we get 15 tens, that's actually 5 tens and 100. That's why the 5 went in the tens column and the 1 got carried to the 100 column. Finally, we add the 1 plus 3, and we get 4. So 454, but we had to do carrying to get there. Another example, let's add 32,285 plus 149,761. To write it vertically, the ones spots have to match up, the 10 spots have to match up, the 100 spots have to match up, the commas have to match up, the thousands have to match up, the 10,000s have to match up, and then we have that 1 in the 100,000s in that one number, nothing in the other number. We can imagine a 0 there when we get to the adding process. Then we add from right to left. 5 plus 1 is 6. 8 plus 6 is 14. Put down the 4, carry the 1. 1 plus 2 is 3, plus 7 is 10. Put down the 0, carry the 1. 1 plus 2 is 3. 3 plus 9 is 12. Put down the 2, carry the 1. 1 plus 3 is 4. 4 plus 4 is 8. And then finally, the imaginary 0 plus 1 is 1. 182,046. There are some numbers with special properties when we talk about addition. The sum of 0 and any number is that number. For example, 7 plus 0 is 7, or 0 plus 7 is 7. It doesn't matter if we're adding the 0 second or if we're adding the 0 first. Anything plus 0 is itself. Next, you might notice that we can add any two whole numbers in any order, and the sum is the same. For example, 4 plus 5 is 9, and 5 plus 4 is 9. This special property has its own name, and that name is the commutative property. And it's referred to as the commutative property because commute means move. Your morning commute is when you go from one place to another. We're physically picking up the 4 and the 5, and we are moving them. We are changing their order to get 5 plus 4. But both 4 plus 5 and 5 plus 4 are 9. So we have the fact that changing the order of two addends does not change their sum. Another example would be 2 plus 3 equals 5 and 3 plus 2 equals 5. We can change the order. It does not change the sum. Another property of addition is the associative property. The associative property says that changing the grouping of addends does not change their sum. You could remember this because the people you associate with are your group. For example, if we're adding 3 and 5 and 7, we can group the 5 and the 7 and add that first. 5 plus 7 is 12. And then we could add the 3 on and get 15. If we change the grouping and instead of doing 5 plus 7 first, do 3 plus 5 first, then 3 plus 5 equals 8, and then adding on that 7 also gives us 15. So changing the group does not change the sum. That's only for addition. Subtraction, instead of a sum, we'd be finding a difference. The word for the result of a subtraction problem is difference. And the order matters when finding a difference. For instance, if you have $8 and someone borrows $3, you have $5 left. On the other hand, if you had $3 and someone borrowed $8, you'd be in the whole $5. You'd have negative 5. But we're not talking about the idea of negative numbers yet. If we break down a subtraction problem, just like the things that are added together are called addends, and there's no difference between the first addend and the second addend because we can add addends in any order. Here, we have a special name for the first thing to the left of the minus sign and the second thing to the right of the minus sign. They have two different names because, again, order matters. The minuend comes first, and the subtrahend comes second. Again, the answer for the word for the answer of a subtraction problem is difference. To subtract whole numbers, we do the same thing that we did for addition. We start in the ones place, and then the tens place, then the hundreds place, and so on. We have an answer here of 7,321, but what's the question? The question is 7,826 minus 505. I forgot to put that in the form of a question. What is 7,826 minus 505? Correct. Sorry, I was playing Jeopardy over here. So we're going to line up the numbers vertically once again so that the place values correspond. Line up the ones place value, the 6 with the 5. Line up the tens place value, the 2 with the 0. Line up the hundreds place value, the 8 with the 5. Line up the thousands place value, the 7 with the nothing, the 0 that we can imagine there. Why this order? Because left minus right has to be top minus bottom. When we subtract, 6 minus 5 is 1. 2 minus 0 is 2. 8 minus 5 is 3. 7 minus nothing is 7. We go from right to left, just like adding. And the reason we have an order when we add is because we're going to encounter carrying when we add. The reason we have an order when we are subtracting, a right to left order, is because sometimes we might have to do borrowing. The answer is 18. The question, what is 81 minus 63? We encounter the need to borrow when the number on top is smaller than the number on the bottom, or when the number on the bottom is bigger than the number on top. Because when we go 1 minus 3, we can't do 1 minus 3 without going negative, and we don't know what negative is. Not yet. 1 minus 3, then, we can borrow a 10 from the tens column, dropping that from 8 tens to 7 tens, but stealing a 10 enables us to go 10 plus 1 is 11. So we steal 1 from the left, and 1 becomes 11, not 2, because we borrowed a 10. So we have to add 10. 1 plus 10 is 11. And then 11 minus 3 is 8. 7 minus 6 is 1. Easy peasy. We're done with subtraction, right? We did the thing that we can do, and then we did the thing with the borrowing, and there's more. Okay. Zeros. Zeros in the first number. When we set this up, we go 0 minus 4. And we can't do that. So we go to borrow 1 from the left. Ooh, there's nothing there because it's another 0. So we have to borrow there. We go to the left. The 9 becomes an 8. We stole 100. That's 10 tens. So now we can subtract in the second column, but we haven't done the first column yet. That first column still says 0 minus 4. We go to try to borrow now from the left, and now instead of a 0, there's a 10 there. So we take 110 from that 10 tens, lowering it to 9 tens and turning our 0 into a 10. Ten minus 4 is 6. 9 minus 7 is 2. And then 8 minus 7, or sorry, 8 minus 1 is 7. So the 0 minus 4 became a 10 minus 4. 10 minus 4 is 6. The 0 became a 10, became a 9 in the middle. 9 minus 7 is 2. And the 9 became an 8 on the left. 8 minus 1 is 7. So the process of borrowing across zeros is tricky, and you might want to practice that. Let's move on to find the perimeter of a polygon. A polygon is any flat figure formed by line segments connected at their ends. So if you draw a bunch of lines and they connect in the end, you have a polygon. So they can be nice figures like this rectangle or this square or this triangle, or they can be weird looking like the one we're going to see on the next slide. But no matter what the polygon looks like, the perimeter is the distance around. In other words, it's the sum of the lengths of its sides. Pick a starting point, walk around it. When you get back to where you started, you stop. Walk around the perimeter of a building means walk around the building. The distance you've walked is the perimeter. The sum of what you walked, the sum of the sides. So here's that weird looking figure I promised. That is a polygon. It's a bunch of lines that connect. Find the perimeter, pick a starting point and walk around it. I'm going to pick that point at the top. 5 plus 4 plus 3 plus 6 plus 8. I'm going to add the sides. You didn't have to do 5 plus 4 plus 3 plus 6 plus 8. Maybe you went the other direction. 8 plus 6 plus 3 plus 4 plus 5. That's fine, as long as you stop before getting that 8 again. Or maybe you picked a different point. Maybe you picked the point on the left instead of the point at the top, and then you went 4 plus 3 plus 6 plus 8 plus 5. That's fine. Or maybe you picked the point on the left and then you went clockwise. 5 plus 8 plus 6 plus 3 plus 4. No matter where you start, as long as you end in the same spot, and whether you go left or whether you go right, clockwise or counterclockwise, Well, left would be counterclockwise, right would be clockwise. That's only if you're thinking about it the same way I am. Sorry. I drifted off my point. My point is that you're going to get 26 inches no matter what. So perimeter is a type of word problem that requires addition. Some other problems that require addition might use keywords or phrases such as added to, plus, increased by, more than, total, or sum. For instance, 2 added to 3 is 2 plus 3. 5 plus 93 is 5 plus 93. 13 increased by 5 is 13 plus 5. 9 more than 30, 9 plus 30. The total of 3 and 5, 3 plus 5. The sum of 391 and 3, 391 plus 3. For some of those, I'd make the argument that the English language would have us add them in the other order. But the beautiful thing about addition is it doesn't matter what order you add in. But for subtraction, you've got to get a lot more specific. Some keywords that we might see that indicate that we have a subtraction word problem are obviously subtract would mean subtraction. But we would need to keep an eye out for difference, less, less than, take away, decreased by, and subtracted from. An example of each. Subtract 2 from 7 means we're starting from 7 and subtracting 2 from it. So subtract 2 from 7 would be 7 minus 2, not 2 minus 7. For difference, the difference of 13 and 1 just follow the same order that it's given in. The difference of this and this is this minus this, 13 minus 1. 19 less 5. Well, if you started as 19 and now you're less 5, you're 19 minus 5. Less than 3 less than 24. You'd start with 24 and you'd subtract 3, 24 minus 3. But 16 take away 4, you're starting with 16 and you subtract 4, 16 minus 4. 8 decreased by 7, you're starting with 8 and you're decreasing it by 7, you're subtracting 7, 8 minus 7. But 6 subtracted from 14, you're starting with 14 and you're subtracting 6 from that, 14 minus 6. Right now, when we don't know or consider negative numbers, it's pretty easy to just put them in the order that gives you a positive result. But you can't do that once we allow for negatives. So you do have to learn what these mean. An example involving adding. The state of Hawaii has 1,851 miles of urban highways and 2,291 miles of rural highways. By the way, notice these are numbers in the thousands, but there's no comma. When it's just a 4-digit number, the comma is optional. But if there were 10,000 or more, the comma would have to be there. But 9,999 and less, optional comma. Anyway, that's not this lesson. Find the total highway mileage in Hawaii. That's this lesson. So the total highways would be the urban plus the rural. So we add the numbers. Total indicates addition. 1,851 plus 2,291. We'd write them vertically. We'd add. We get 4,142 miles. Feel free to pause and practice addition. Make sure you get that number. Dilys King is reading a 503-page book. If she has just finished reading page 239, how many more pages must she finish to read the book? So what does she have? Well, total there's 503, but she's less 239. She's done 239 of them already. We can subtract those away from the 503. So this sets up subtraction, 503 minus 239. Set it up vertically. Try it on your own if you want. Make sure that the answer you get is 264. As years pass, the number of endangered species per country increases. In the following graph, each bar represents a country, and the height of each bar represents the number of endangered species identified in that country. Let's look at this graph on the next slide. Which country shown, not county, which country shown had fewest threatened amphibians? Which bar is the smallest? That would be China at 92. Don't just assume because it's on the right that it's the smallest. I actually looked at every number and made sure that 92 was the smallest number there. But with 92 threatened amphibians, China had the fewest. Another question concerning this same data. Find the total number of threatened amphibians for Brazil, Peru, and China. So now that we've reviewed how to read the graph, now we have something that involves what we've done in this lesson. Finding the total number is adding. So we'd be adding Brazil, Peru, and China. Brazil is 116, plus Peru is 96, plus China is 92. We add those together, we get 304. And that is it for this topic.